Here I am talking about Henry's law problems. Question 1. If nitrogen is bubbled through water at 293 Kelvin, how many millimoles of nitrogen gas would dissolve in 1 liter of water? Assume that nitrogen exerts a partial pressure of 0.987 bar. Given that Henry's law constant for nitrogen at 293 Kelvin is 76.48 kilobar. Nitrogen is bubbled through water. It means nitrogen is solute. Water is solvent. They are asking to find out millimoles of nitrogen gas dissolved in 1 liter of water. 1 liter of water means 1000 centimeter cube water. Given that nitrogen exerts a partial pressure of this much. So 0.987 bar means partial pressure of nitrogen. Then Henry's law constant given 76.48 kilobar kH. Then in terms of bar it becomes 76.48 into 10 raised to 3 bar. For answering this question we use Henry's law equation. Partial pressure of nitrogen is equal to Henry's law constant kH into mole fraction of nitrogen gas. First, you can find out mole fraction of nitrogen. Chi nitrogen is equal to partial pressure of nitrogen divided by Henry's law constant. Substituting the values. Partial pressure of nitrogen 0.987 bar. Then Henry's law constant 76.48 into 10 raised to 3 bar. On solving we get the value 1.29 into 10 raised to minus 5. Then on solving a mole fraction of nitrogen we get moles of nitrogen. Mole fraction of nitrogen equal to number of moles of nitrogen by number of moles of water plus number of moles of nitrogen. In the denominator, number of moles of nitrogen can be neglected. Why? Because if you look at mole fraction of nitrogen, the value is very small, 10 raised to minus 5, is very small. It happens when number of moles of nitrogen is far less than number of moles of water. So you can neglect moles of nitrogen in the denominator. Question becomes mole fraction of nitrogen becomes number of moles of nitrogen divided by number of moles of H2O, water molecule. Then in the question it is given 1000 centimeter cube water. 1000 centimeter cube water means number of moles of water. How much number of moles of water? Number of moles of water is equal to mass of water. Mass of water 1000 centimeter cube is same as 1000 gram. Density of water is 1. So 1000 centimeter cube is nothing but equal to 1000 gram divided by molar mass of water 18 gram. Its value will be 55.55. So we can substitute or you can find out number of moles of nitrogen. Number of moles of nitrogen. Number of moles of nitrogen is equal to mole fraction of nitrogen into number of moles of water. What is mole fraction of nitrogen? 1.29 into 10 raised to minus 5 into number of moles of water 55.55. On solving we get 7.16 into 10 raised to minus 4 moles. Here they are asking millimoles. So moles can be converted to millimoles multiplying with 1000. So 7.16 into 10 raised to minus 4 into 1000 millimoles equal to 0.716 millimole. So correct option is 4. Question 2. Hydrogen sulfide, a toxic gas with a rotten smell, is used for the qualitative analysis. If the solubility of hydrogen sulfide in water at STP is 0.195 molar, calculate Henry's law constant. Here we have to calculate Henry's law constant KH. What is Henry's law equation? Partial pressure of the gas, here it is hydrogen sulfide gas, is equal to Henry's law constant into mole fraction of the gas. Here it is hydrogen sulfide gas. So partial pressure of hydrogen sulfide is equal to KH into mole fraction of hydrogen sulfide. Rearranging we get Henry's law constant. KH is equal to partial pressure of hydrogen sulfide divided by mole fraction of hydrogen sulfide. Then partial pressure of hydrogen sulfide, it is directly given here. STP. STP means partial pressure of hydrogen sulfide is taken as 1 atmosphere. 1 atmosphere. So numerator is known. Then denominator. Denominator means mole fraction of hydrogen sulfide. How is it obtained? Mole fraction of hydrogen sulfide is equal to number of moles of hydrogen sulfide by number of moles of water plus number of moles of hydrogen sulfide. Here this one is solute, hydrogen sulfide is solute, water is solvent. Okay, then number of moles of hydrogen sulfide, number of moles of water, they are not directly given. Instead in the question you can see solubility of hydrogen sulfide is given in terms of molality. When you analyze this molality term, you will get NH2S as well as NH2O, correct? So solubility it is given as 0.195 molar. It means we have 0.195 moles of H2S present per 1000 gram of water. Okay, then 0.195 moles. It represents number of moles of H2S. 1000 gram you can calculate number of moles of water. H2O is equal to 1000 by molar mass 18 comes out to be 55.55. So what is chi H2S? Chi H2S is then NH2S. NH2S means 0.195. 0.195 by NH2O 55.55 plus 0.195. Solving this, we get value as 0.0035. You have to substitute this value here. PH2S we have already explained. It is nothing but 1 atmosphere. Chi H2S 0.0035. So Henry's law constant equal to 1 by 0.0035. Answer is 285.7 atmosphere. Option 2 is correct. Question 3. Henry's law constant for CO2 in water is 1.67 into 10 raised to 8 Pascal at 298 Kelvin. Calculate the quantity of CO2 in 500 ml of soda water when packed under 2.5 atmosphere CO2 pressure at 298 Kelvin. In this question, CO2 is solute and water is solvent. We have to calculate quantity of CO2, means WCO2. For solving this problem, we use Henry's law equation. PCO2, partial pressure of CO2 is equal to Henry's law constant into chi CO2. Then chi CO2 equal to PCO2 by KH. PCO2 given in the problem 2.5 atmosphere. This is PCO2. So PCO2 2.5 Chi KH given here. This is KH. KH is 1.67 into 10 raised to 8 Pascal. So numerator we have atmosphere. So denominator also should be in atmosphere. Multiplying with 1.013 into 10 raised to 5. Then it becomes atmosphere. On solving, the value will be 1.52 into 10 raised to minus 3. Then chi CO2. Chi CO2 is equal to NCO2 by NS2O plus NCO2. In the denominator, you can neglect NCO2. This is because if you look at chi CO2 value, it is in the range of 10 raised to minus 3, very small, very small. It becomes very small. Why? Because NCO2 is far less than NH2. Number of moles of CO2 is far less than number of moles of water. That's why we have neglected NCO2 in the denominator. So chi CO2 equal to NCO2 by NH2O. NH2O. Chi CO2 we have already found out 1.52 into 10 raised to minus 3. NCO2 means WCO2 by molar mass 44. NH2O, WH2O. WH2O, it is given WH2O. It is 500 ml. 500 ml means 500 gram. Density of water is 1. So it is 500 gram. Here it is given as soda water. Soda water, number of moles of carbon dioxide present is negligibly small. So 500 ml of soda water means it is simply 500 ml of water itself. So it's 500 gram. So when you substitute 500 by 18 NH2O, instead of NH2O we will be substituting 500 by 18. Then on simplifying 18 by 500. Solving this, the value of WCO2 comes out to be 1.86 gram. So option 1 is correct. Okay.